Now that you've learned how to actually evaluate given two different functions, now we're going to talk about creating a new function from two different functions. So we'll actually be creating a composite function. So just to remind you that f of g of x is the same thing as writing f of g of x, so you can write it in two different ways. This does not mean fog. G of f of x is g of or g following f of x. It can be read either way. Remember, we always start with the inside function. So before, we took a number and started by putting it in our inside function, got a new number, and then put that new number into our outside function, evaluated that, and we were done. Now, we're not going to have a number. We're just going to have a variable. So what that is going to mean, since we don't know what the variable is to plug the inside function into the outside function. So what does that mean? It means to substitute the inside function for every single variable you find in the outside function. And then once you do that, you'll simplify if possible. So we're going to look at 3 examples where I show you what this means. So the first example is just going to be one single example. The second 2 will each have a part A and a part B. The third example would be a good one for you to try after seeing me work through 1 and 2, and that way you can compare what you can do to what I do once you restart the video. So let's look at example 1 here. So I'm told f of x is 2x plus 3. I'm told g of x is x squared minus 2. I'm asked to find f following g of x. So the first thing I always do is I always say, okay, I'm going to rewrite that with parentheses so it's very clear for me what my inside function is versus my outside function. So before I took my number that was here and I plugged it into g. Since this is just an x and x is already in g, I'm now going to say, well, I'm going to take that inside function, I'm going to take g of x, and I'm going to substitute that whole function into f. I do that by placing g of x, by placing x squared minus 2 into each variable of f. So if I start by rewriting my f, I have a 2. As soon as I hit a variable, I'm going to replace the variable with x squared minus 2. I have to finish writing f, so I'm also going to drop down the plus, and I'm also going to drop down the 3. So notice the 2 stayed, the plus 3 stayed, and x changed to g of x, which was x squared minus 2. That is how I plug my inside function into my outside function. Now I have to try and simplify. Well, I see I can distribute a 2, so I'm going to go ahead and do that. I'm going to take my 2 and distribute it to both the x squared and the minus 2, and have 2x squared minus 4 plus 3. After distributing, I see I can also combine negative 4 and positive 3 to get negative 1. So my final answer will be 2x squared minus 1. That is my new composite function after putting g of x into f of x. Looking at the second example, I'm going to take the same steps. Notice now I have a part A and I have a part B. So I'm first going to look at part A. So part A tells me to find, and I'm actually going to move this over a little bit. Part A asks me to find f following g of x. Well, I know that's the same thing as f of g of x. So I'm going to take my g of x function, 2x squared minus 4x. I'm going to plug it in for every variable I find in f of x. That's going to give me 3. Oh, I'm running into a variable. I'm running into x. So instead of x, I'm going to write my g, which is 2x squared minus 4x. And then continuing to write my function f, minus 2. From here, I ask myself, can I simplify? Well, yeah, it looks like I can distribute a 3 in to both terms, giving me 6x squared minus 12x minus 2. I notice that from here, there's nothing else I can do. I do not have any like terms, so this is going to be my final answer. This equation here, this new equation is equivalent to f following g of x. And like I said, that is my final answer. Looking at example 2. With example 2, or example B, or letter B, I guess, I'm going to now, so notice I do not have it written in the same notation. I've already got that first step for me. I've already have it written with an inside function and an outside function. So I'm going to start with my inside function, which this time is f of x. So I'm going to start here at f of x. I'm going to plug it in to every variable I see in g of x. Well, in the past, or 2 examples, I only had 1 variable, now I have 2. So I'm going to start writing g, and I write 2, and I hit a variable. As soon as I hit a variable, in place of that variable, I'm going to put 3x minus 2. I'm going to drop down my square from my g, drop down my minus, drop down my 4, and then I run into another variable. I am going to put 3x minus 2 in for that other variable. From here, I ask myself, can I simplify? Well, order of operations says before I distribute the 2, I should take care of my exponent. I know that 3x minus 2 squared, doing a little scratch work down here, means 3x minus 2 times 3x minus 2. Using FOIL, I get 3x times 3x is 9x squared. 3x times minus 2 is minus 6x. Minus 2 times 3x is another minus 6x. Minus 2 times minus 4 is plus 4, giving me 9x squared minus 12x plus 4. So going back to my function, I'm dropping down the 2 because I haven't had a chance to distribute that. Instead of 3x minus 2 squared, in place of this piece right here, I'm going to put 9x squared minus 12x plus 4 in. I still have my minus 4 and my 3x minus 2. Continuing to see if I can simplify, now I can distribute in my 2. I can also distribute in my minus 4 because sign belongs to the number, giving me 18x squared minus 24x plus 8 minus 12x plus 8. So notice this process relies very heavily on your algebra skills in terms of, do you know how to FOIL? Do you know how to do order of operations? So all that's going to come into play. Looks like I can still simplify further. I don't have any other x squared terms, so I'm going to leave that 18x squared. But I can combine a minus 24x and a minus 12x, giving me a minus 36x. And I can combine an 8 and an 8, giving me 16. That will be my final answer for g of f of x. As I said, I have a total of 3 examples. If you wanted to pause the video after copying down the 3rd example and try it on your own and see how you can do, and then you can compare your work to my work. There is both an A and a B. Okay. Now that you've had a chance to try one on your own, I'm going to go ahead and go through them. Part A asks me to find g following f of x, which I know is the same thing as g of f of x. So that tells me to start with my inside function, start with my f of x, and plug it into any variables that I have in my g of x. So as soon as I start writing g of x, I realize that with g of x, right away I run into an x squared. So in place of x, I'm going to put my f, which is x minus 4. I'm going to keep the square, keep the minus, keep the 2. And then when I run into my next x, this one here, I again am going to replace that with x minus 4, which is my f. And then once again, I'm going to keep the plus and I'm going to keep the 7. So now I'm going to go ahead and I'm going to see if I can simplify this. Well, I can simplify, see right away, x minus 4 squared. I know x minus 4 squared means x minus 4 times x minus 4, which I know becomes foiling x squared minus 4x plus 16. Combining like terms in the middle gives me x squared minus 8x plus 16. I am going to take that quantity and I'm going to replace x minus 4 squared with that amount, giving me x squared minus 8x plus 16 minus 2 times x minus 4 times plus 7. Following my order of operations, now that I've done the exponent, now I can multiply, so I can distribute my minus 2 in. Everything else will stay the same. And now I check to see if I have like terms. I don't have any other squared, so I'm going to leave x squared. Minus 8x and minus 2x becomes minus 10x. 16 plus 8 is 24. I guess I could do a different. 16 plus 8 is 24, plus 7 is 31 for my final answer. Looking at part B, I'm basically going to do the same thing, except for now I'm starting with my g of x function, and I'm plugging it in. Oops, excuse me, not that one. I think I just erased some middle stuff, trying to erase the last thing I did. So I'm sorry, some stuff just disappeared. Hopefully you got that copied down. If not, rewind the video and copy that down before I erased it. So I'm going to start with g of x, and I'm going to plug it in for every variable that I have in f. So I go to recopy f down, and I see I run into a variable right away. So in place of this x in f, I'm going to put x squared minus 2x plus 7. I still need to put down the minus 4. From here, I see if there's anything I can do to simplify, and I see the only thing I can do to simplify is combine a 4 and a minus 7, giving me x squared minus 2x plus 3. So as you can see, these vary in difficulty level once you've substituted in your inside function. Sometimes there's a lot of algebra to do, like in this one. Sometimes there's not a lot of algebra you can do. Like I said, it'll vary from problem to problem. Lastly, I keep giving you the same example video after video after video. You're finally at a point where you should be able to do this problem. You have all the pieces to answer A through D. So you may have this on another sheet. You may have already started it. Go ahead and retry or finish any of the parts that you were unable to do before, and we'll talk about it tomorrow in class.